Hello. Listen. Now we discuss third unit of this session. That unit is the line. This unit line is the three-dimensional structure, and it is one of the important unit in this section. Okay. Now we discuss theoretical part of line that contains equation, convergence, q line, shortest distance, and foot of the perpendicular, etc. Now firstly we discuss the theory and discuss some examples related to this unit. First is that equation of the line. Every part of the line, theoretical concepts related to the line, you are already discussed in the board textbook. Okay. Now we summarize that equation of the line part in this table. Just check that table. First is our target is to find equation of the line, but some data given, that is the first column given vector equation and Cartesian equation. You remember that equation of the line, there are the single equation described in two parts, vector equation and Cartesian equation. Both are important. Okay. There are three parts or the three rows given here. That is the firstly given sometimes a bar be the point, b bar be the parallel vector to the line. These are the given quantities, and our target is to find the equation of the line. We firstly find the vector equation and Cartesian equation. Formula is like that: a bar is equal to r bar is equal to a bar plus lambda b bar. R bar is equal to a bar plus lambda b bar, where a bar be the point and b bar be the parallel vector, and Cartesian equation is that x minus x1 upon a, y is equal to y minus y1 upon b is equal to z minus z1 upon c. One of the most important part, that is this equation is x minus x1 upon a, listen again, is equal to y minus y1 upon b is equal to z minus z1 upon c. Now when 2 points a bar and b bar, capital A and capital B, sometimes in the Cartesian, now example number 2. The equation of the line passing through the point A, B, C and parallel to z axis. Very nice question. A, B, C is the point here, not a DRS, and parallel to z axis. Options are given here, but we discuss solution. Check that point is the A, B, C, and parallel vectors is z axis. Therefore, what is the DRS of this z axis? DRS of z axis are 0, 0 and 1. 0, 0 and 1. Therefore, equation of the line in Cartesian form, x minus x1 upon a equal to y minus y1 upon b equal to z minus z1 upon c. This gives us that x minus a upon 0 is equal to y minus b upon 0 is equal to z minus c upon 1. Therefore, the solution of this example number 2 is the option B, which contains this equation. Okay. Next. Now we discuss example 3. The distance of the point of the intersection of line x minus 3 upon 1 equal to y minus 4 upon 2 is equal to z minus 5 upon 2, and the plane x plus y plus z is equal to 2 from the point 3, 4, 5. This question is one of the most important question. It is also important for JEE. Check that our target is to find the distance of the point which is the 3, 4, 5, but along with this line to this respective plane. Therefore, we write the first equation of line x minus 3 upon 1, y minus 4 upon 2, z minus 5 upon 2 inequality, and plane x plus y plus z is equal to 2. The point 3, 4, 5, firstly observe that 3, 4, 5, this point is present in the line x minus 3 upon 1 and so. That is, it is present on the given line. In short diagram like this, 3, 4, 5 is the point here, plane is in short remain, and M is the foot of the perpendicular. This is not the perpendicular distance, it is the line which is given here. Okay. Now this plane x plus y plus z is equal to 2. Now my target is to find the point M, then we find this particular distance. Point 3, 4, 5 is available here and M is available here. When we find the coordinate of M, then we succeed to find this particular distance. But this M is present on the line, therefore we find the general coordinate. X minus 3 upon 1 is equal to y minus 4 upon 2, z minus 5 upon 2 is equal to k. When simplify, x minus 3 is equal to k, y minus 4 is equal to 2k and z minus 5 is equal to 2k. Simplification gives us that x is equal to k plus 3, y is equal to 2k plus 4 and z is equal to 2k plus 5. Add the point of intersection, that is the particularly point at M, x plus y plus z is equal to 0. This point is present on the line and on the plane also, therefore we put x, y, z in this equation, that is k plus 3 plus 2k plus 4, 2k plus 5 is equal to 2. After simplification we can obtain k is equal to minus 2. K is equal to minus 2, then we find x, y, z, particularly that is x is equal to 1, y is equal to 0, z is equal to 1. That is, now we succeed to find the coordinate of M and our target is to find the distance of the 3, 4, 5 from the point M using distance formula root of 3 minus 1 square plus 4 minus 0 square plus 5 minus 1 square. This gives us that 2 square plus 4 square plus 4 square, that is 4 plus 16 plus 16, that is the root 36, it is equal to 6. Therefore, required distance of this point is the 6 units. It is one of the most important question, and this question is also important for JEE. Therefore, prepare carefully. Example number 4. Angle between the lines. Angle between the lines. There are two lines. 2x plus 2x is equal to 3y is equal to minus z, and 6x minus is equal to minus y is equal to minus 4z. Then our target is to find an angle between them. We firstly write these equations in the proper format of the equation of line in the Cartesian form. Therefore, x upon 1 by 2 is equal to y upon 1 by 3, z upon minus 1, and x upon 1 by 6, y upon minus 1, z upon 1 by 4 in this way. Then these two equations are given here, but these denominators are just fractions. Therefore, we can choose them as the element, that is L1 M1 N1, L1 L2 M2 N2. Therefore, cos of theta is nothing but the mod of L1 L2 plus M1 M2 plus N1 N2, that is 1 upon 12 minus 1 upon 3 plus 1 upon 4 with the particular multiplication. When we take the denominator 12, numerator simplified as 1 minus 4 and 3 plus 3, then this simplification gives us that is equal to 0. But remember that this is the value of cos theta, therefore theta is equal to cos inverse of 0, and angle between them is the 90 degree, and the option D is of the 90 degree, and which is present in this one, and which is correct solution. We now discuss example number 5, very short question, and in 3-dimensional geometry, equation x square plus y square is equal to 0 represents. We have discussed such type of the equation in the conic section also, but this is the different. It is the in 3-dimensional geometry, x square plus y square is equal to 0. Therefore, you remember that. Firstly, write down this equation, x square plus y square is equal to 0. In this case, x, y and z coordinates available because of it is the 3-dimensional structure. Therefore, this LHS holds if and only if x is equal to 0 and y is equal to 0 in 3-dimensional geometry. Therefore, in 3-dimensional geometry, x equal to 0 and y equal to 0, this is this is the first plane and this is the second plane. When these two planes intersect to each other, then we obtain z axis. Therefore, this equation represent z axis, and which is the option C. Now, example number 6. Very simple question. Coordinate of the foot of the question. Coordinate of the foot of the perpendicular from the point ABC on the z axis. Our target is to find foot of the perpendicular from this point to the z axis, and these options are given here. We focus on the solution. Given point is the ABC. So, perpendicular distance of this point from the z axis, that is must be C. Therefore, the required point of the foot of the perpendicular is 0, 0, C. This question asked if related to the y axis, then it is the 0, B 0, and related to the x axis, then it is the A 0, 0. Therefore, be careful in such type of questions, and which is the correct in the B solution, that is the 0, 0, C, which is available. It is the example number 6. This is the topic line.